All right, I am going to go through here and explain the review. I'm doing this because I will be traveling with kids during some of my classes tomorrow, and I want to make sure everybody has the same opportunity to answer questions. So Unit 9 test review, because I'm giving you the answers, I will not be grading it. Anytime I am saying expand, I'm wanting you to use the product, quotient, or power rule. So since we're multiplying, I'm going to apply the product rule. My first step will be to expand it to log base 7 of A plus, because we're multiplying, log base 7 of B to the 4th. But I'm not fully done yet because there are still some exponents. So my final answer would be log base 7 of A plus, by power rule, this gets to come down, 4 log base 7 of B. Final answer. Over here, same thing, except since this is an exponent, it's going to have to come down. So my final answer here is log base 2 of C to the 4th, but that 4 is going to come down here, plus log base 2 of D. Okay. Here, number 4, expanding. I'm not multiplying anything here. I'm not dividing anything here, but remember, I can write the square root of y as y to the 1/2 power, right? Those are equal. So then using power rule, this guy can come down since I'm taking the log. So this is 1/2 log of y. Over here, this is the quotient rule. So since we're dividing, this is simply equal to log base 5 of m minus log base 5 of n. Okay. Over here, now we're going in the opposite direction. We're wanting to condense. Up here, we applied the power property last. Here, we're applying the power property first. So since we have a log here, I can take this exponent and put it back. I can take this exponent and put it back. This does work both ways. So this would be log base 5 of A to the 6th power plus log base 5 of B to the 4th power. And since we're adding, my final step to condense these would be log base 5, since these have the same base, of A to the 6th, B to the 4th. Over here, again, I'm going to take this and I'm going to put it back as an exponent, back as an exponent. I'm adding, so I'm using product rule. So final answer is log base 3 of C squared D to the 8th. All right, here, again, I'm going to take this and put this as an exponent, and I'm subtracting. So I have log base 2, since I'm subtracting, that's going to be my quotient rule, of x to the 1/2 over y. But remember, x to the 1/2 means square root x. So there would be your final answer. So go back and look at your quotient rule if you're confused. Over here, again, I'm going to apply power first. And I'm subtracting, so this is going to be quotient. Log base 7 of u over, if I do v to the 1/2, that's square root v. And I'm not concerned with you rationalizing now. I'm just wanting to see if you've got the rule. All right, so this right here is the graph of y equals 4 to the x. That's your parent function. So all I'm wanting you to do is really tell me what happens when you do this function. Okay. Now you're going to have your graphing calculator on the whole test, so feel free just to plug that in and see what happens. Okay, but here if we have an x minus 2 inside the function or up there, this is going to move your whole function left 2. So look at your 9-4 notes if you're confused about that. So we are currently crossing here, but we would need to move that over 2 places. It doesn't affect our horizontal asymptote, so every single position that you have here is going to move over 2 places. So I'm counting by ones here. They counted by 4s. Let's see, that's the point 2, 8, or really like 216 probably. So as long as it looks like it's growing here, it doesn't want to go through that place actually. We're heading up this way because we moved over left 2. And that's all you'd have to do on that. Over here, again, this plus 3 means that it moved the function up 3. Normally you have a horizontal asymptote here at y equals 0, and we usually cross here, but now we're moving up 3, so 1, 2, 3, 1, 2, 3. So it's going to look like this. All right, and simple sketch, not looking for anything fancy. All right, next page. Here, my biggest recommendation to you is to graph it in your calculator. I'll do it algebraically here. Because both of those have a negative, you first need to factor out the negative, and that's an x plus 3. So this negative is going to reflect over the y-axis, and the plus 3 is going to move this left 3. But again, if you don't want to worry about do I need to factor, when do I not need to factor, just plug this in, log of negative x minus 3, close your parenthesis, and graph it, and you'll see kind of how that works. And just so that you understand, I'm going to put log of normal x in there. Log of normal x should look like this. So you can tell that it flipped over the y-axis and it moved over 1, 2, 3 positions. So even if you didn't know you had to factor, by looking in your calculator, you should be able to get there. The domain of a log function, let's think about it. If the function looks kind of like this, we're never going to cross, and we have a horizontal or a vertical asymptote at 0, but we moved that 3. The whole function is always going to be to the left of negative 3. So here your domain is less than negative 3. Never equal, because it's not going to hit that. The range of a log function is always all real numbers. It's going forever down, it's going forever up. Asymptote should normally be at x equals 0, but because we moved left 3, the asymptote moved over left 3. Okay, same thing over here. I would graph it just to verify, but the negative out front reflects over the x-axis. And the plus 2 is going to move the whole function up 2. So just get a sense of what that looks like here. It is, normally should be doing this, so if it reflected and then moved up 2, then we're doing something like this. Again, we can graph this. So normal one should be just normal log x. Our new one is negative log x plus 2. So there's our normal. Here's our new. So again, my domain, the furthest it's going to go is to my asymptote, and it's going to go forever to the right. So domain is, as it should be, because we didn't move any left or right, greater than 0. Range is always all real numbers, and the asymptote didn't move any left or right, so it's still the line x equals 0. All right, solving these, the absolute simplest way to do any of these is if you can rewrite the base, do so. So what I'm going to do is 5 to the negative 4x equals 5 cubed. Since these have the same base, I can set these guys equal to one another. So x equals negative 3/4. Over here, again, I can make 64 a power of 2. That's 2 to the 6th power. Set these guys equal. Negative 5x equals 6. So x is equal to negative 6/5. Over here, 3 to the 2x minus 5. I can rewrite this as 3 cubed. So set these equal to one another. 2x minus 5 equals 3. So 2x equals 8. Divide both sides by 2. X is equal to 4. Over here, 4 to the 6 minus 2x is equal to what is that? 4 cubed. Okay, 4 cubed. So then I can set these equal to one another. 6 minus 2x is equal to 3. Subtract a 6. And divide by a negative 2. So you get positive 2/3. Positive 2/3. Go 4/3. Is that accurate? Yes, that's fine. Nope, 3/2. I was going to say that did not look right. Okay, right, if I divide by 2, that's going to be 3/2. Sorry, guys. Okay. Over here, that's not going to be so easy, right, because it's a different format. I don't have 2 bases. But remember what this means in exponential. The base would be x, the exponent would be 7, and it's equal to 2,187. Well, I need to take the 7th root. And remember to do that, you type the number first, so root 7, math 5, and then just type in the number. So that's 3. Worst case scenario, you don't remember how to do that on test day. What's 2 to the 7th? Nope. What's 3 to the 7th? Yup. Okay, so x equals 3. Over here, again, rewrite x cubed equals 343. If you don't remember how to take the cube root, simply do 2 cubed, 3 cubed, and you could keep going, but cube root is math 4. And what is that? 343. Should be 7. Okay, there you go, 7. All right, moving right along here. Again, I would rewrite this anytime you can. 3 to the 0 power is equal to 3x plus 6. Anything to the 0 power is 1. And this becomes an algebra problem. Subtract a 6. Divide by 3. Rewrite 4 to the first power is equal to 6x minus 7. Add a 7. Divide by 6. Over here, I can't make 27 a power of 4, right? 4 squared is 16, 4 cubed is 64. I pass right over it. So this is where I actually have to start taking logs. So I'm going to take the log of this side and the log of this side. And remember, anytime you take the log, the exponent can come down by the power rule. So 2x plus 3 log 4 is equal to log 27. I'm going to divide both sides by log of 4. So I have 2x plus 3. I'm just going to figure out what this decimal is in my calculator. So the log of 27 divided by the log of 4. That gives me 2.377. Then it's just algebra. Subtract a 3, divide by 2. So subtract a 3, divide by 2. And my final answer is negative 0.62. Okay, over here, same thing. In order to get this exponent down, I need to take the log. So I have 2x minus 7 log 3 equals log 15. We're going to divide both sides by log 3. So we have 2x minus 7 is equal to whatever this decimal is. So 2.465-ish. Add 7, divide by 2. So I got 4.73. Over here, to cancel out an e, I'm not going to take a log. I'm going to take the natural log. So that cancels. I have 8x minus 3 is equal to whatever the natural log of 50 is. Add 3, divide by 8. So in my calculator, I'm going to do the natural log of 50, then add 3, then divide by 8, and you should get 0.86. Same thing, natural log, Subtract a 4, divide by 6. So if you did that correctly, you should get negative 0.01. Over here, let's isolate our e first. So I'm going to need to add 14. So if I add 14, that'd give me, what is that, 25? And then I am going to need to divide by 3. Okay. Then to cancel out that e, I'm going to need to take the natural log of both sides. So x is equal to whatever the natural log of 25/3 is. So I got 2.12. Right over here, isolate first, so subtract a 22. Divide by 6. Take the natural log. So 7x is equal to the natural log of 5. Then divide both sides by 7. So natural log of 5 divided by 7. You should get 0.23 after rounding. Moving right along here. How do I cancel a natural log? Well, you have to raise both sides by the e power. So that'll cancel, that'll cancel. 7x plus 9 equals x. Then this just becomes an algebra problem. Subtract 7x from both sides. Divide both sides by negative 6. So x is equal to negative 3/2. Over here, again, cancel natural logs on both sides. I'm going to raise both sides to the e. 5x minus 2 is equal to x. Subtract a 5x. Divide both sides by a negative 4, and that's going to give me a positive 1/2. Over here, subtract 5 from both sides. 2 natural log x equals a negative 9. Divide both sides by 2, so that's going to give me negative 9/2. And then to cancel, I need to raise both sides by the e power. So in your calculator, you're actually doing the e to the power of negative 9 over 2. So e, that's second ln, to the negative 9 over 2. And I got 0.01. Final one here, we're going to subtract a 2. Divide by negative 6. And then cancel out your natural log. X is equal to whatever e squared is, and that is 7.39. All right, final questions are these word, okay. So over here, I can't just do e to the both sides because I have some addition. So the first thing that we're going to need to do here is to condense these. So since this is adding, I'm going to use the product rule. So I have the natural log of negative 3x plus 9 is equal to the natural log of 4x, because those are adding, we can multiply, now e to the both sides. So negative 3x plus 9 is equal to 4x, add 3x, divide by 7. Same thing over here, let's condense first. E to both sides. So negative 8x minus 5 is equal to 6x. Add your 8x. Divide both sides by 14. Okay, so those should all be pretty comfortable. Those are algebra skills. All right, here with this one, remember A is kind of like your final amount after time. I is your initial, or P is your initial. This is your rate as a decimal. This is the number of times you're going to compound. So number, and this T is time. So let's just plug everything in. A parent invests $2,800. That's your P. That's going to be your initial amount. 4.4%, that means that your R is going to be 0.044. You've got to make that into a decimal. Compounded monthly, so this makes N. How many times does N happen a year? Well, monthly, that is 12. And in 5 years, there's your T. So we're just going to plug everything in. How much money do I have? A, if I invest $2,800, 1 plus at 0.044, compounded 12 times, and then N times, that's going to be 12 times 5. And guys, enter that in exactly as you see it. So here we go. 2,800 alpha, sorry. 1 plus alpha y equals 1. 0.044 over 12. Get out of that. To the 12 times 5. And if you did that correctly, I got $3,487.61. Okay. Now, using that same information, how long will it take? So how long will I take is asking for T. If I want my balance, or my A, so a better way to say that is your balance, to reach 4,400. Plug everything in, solve for T. So 4,400 is equal to my original investment at 4.4% compounded monthly, but 12 times, I don't know how many years it's going to take. So algebraically, my first step is going to be to divide both sides by 2,800. So what is that? So that's going to be 15.714 is equal to 1 plus 0.044 divided by 12 over 12t. This is why logs are important here. I need to get this down. So in order to get that down, I have to take the log of both sides. So when I take the log, this can come down. So the log of 15.714 is just going to be some decimal, is equal to 12t, 1 plus, oh, no, I need to do the log, sorry. My eraser is not very good here. 12t log of all that mess. And then you're just going to divide both sides by 12 log of this. Okay, all of this. That 12 will cancel there. This will cancel here. That will leave you t. And if you do that calculation correctly, let me plug that in. The log of 15.714 over 12 log 1 plus alpha y equals 1.044 over 12. I got that it's going to take you 62.72 years. It's going to take you a while. You'll eventually get there. All right, last one, calculate the growth rate. That's your B. Okay, we're calculating the growth rate. This is like your final initial growth rate number of times. So here in 2000, or the end of the population that I'm concerned about, is 21,018,316. The beginning amount is 3,845,000. E is just a number. I don't know what B is, but if I'm going from 1900 to 2000, that's a total of 100 years. Okay, so I'm going to begin by dividing both sides by 3,845,000. So 21018,316 divided by 3,845,123. So I got that that is 5.466 equal to e to the 100b. I just rearranged that a little bit. Again, to get my exponent down and to cancel this e, I'm going to take the natural log of both sides. That's just going to give me some decimal, so I'll leave it like that for now. That's going to cancel 100b, and then divide whatever that is by 100. So natural log of that divided by 100, I got my growth rate to be 0.017. Okay, 0.017. And anytime I'm asking for a model, I just want the nice equation that we could write. So back to the initial 3, 8, 4, 5, and 3 zeros. E to, now I know my growth rate, 0.017t. All right, that's it. Good luck on the test.